there's a second part to 6c. You have your variables of the volume being 2 times 10 to the 8th liters. You have your pressure as 1 atmosphere. You have your temperature is at 25 degrees Celsius, so 25 plus 273.2 would be 290, oops, my eraser here, my sock, 298.2 Kelvin, say. And the other thing we need for this is basic understanding of the gas law and using your mole map for this. So I did this part 6, part 6C, part 1. If we think about this, we get our equation, PV equals nRT, right? In the mole map, what we're looking for, right, we're trying to go from moles in the center here, forget what shape it is. We have two volume conversions, right? We have volume at STP, standard temperature pressure, and then we have another volume that is not STP, right? Not at STP, okay? If it's at STP, that means we're going to use our standard volume. So whatever your volume is, you would divide by 22.4 liters per mole, right? So it'd cancel and give you moles if you divide by that. If you have moles, then you want to multiply by that. If you look at your mole map, it's on there. If it's not at STP, we're just going to use this equation here, okay? So we have the volume, right? We're given that in the problem, 2 times 10 to the 8th liters. And we know, so that we have the volume there, and so we're going to multiply by the pressure. So what I'm going to do is I'm going to put that at the top. P will go on top of this line, meaning multiply by there, and then everything below that line, it's similar to your mole map, would be, we're trying to find moles, so that's moles here, right? And so we would divide both sides by RT, so we're going to divide this by RT, okay? So and then if you're going from moles to the volume, it's going to be the opposite, right? If you have the moles, you're going to multiply by RT, and you're going to divide by the P to give you the volume. Okay, so this equation is in the mole map. You can use that. For this problem, from part 1, we said that the R would be 0.082 0 ATM times liters per mole times Kelvin. One of my favorite units. You can actually convert that right to joules. Okay, and so we plug this all in. We're going to have our volume, 2 times 10 to the 8th liters, right? Divided by our times the pressure. Multiply that pressure, 1 ATM, divided by the constant and the temperature. So 298 Kelvin, 0.0820 atmospheres per liter, right? Time divided by mole. So we'll convert this all to moles, right? And then Kelvin will be our unit here. So that our liters will cancel, Kelvins cancel, atmospheres cancel. So if we did this math, we'd get the moles. Oops. Where's my units divided by 0.820 atmosphere liters per mole Kelvin. So those go on the top, canceling liters, Kelvin, atmospheres, left with moles. Now we can look at our chemical equation, which is that 2 moles of H2 plus 1 mole of O2 gives us 2 moles of H2O, right? And it takes an amount of energy, change in enthalpy, amount of heat, of negative, negative 572 kilojoules, right? So when this gives us our moles, we're going to use our mole ratio here, because in this equation, right, we're going to say that 2 moles of, well, no, I'm sorry, not here. We have 2 moles of hydrogen gas. So for every 2 moles of hydrogen gas, we're going to make negative 572 kilojoules. So we can add that right into our problem here. So I have my moles, doing the math. In my equation, I have 2 moles of hydrogen gas. For every 2 moles, it gets this much energy. So I do my mole to mole ratio here, cancel my moles, and now I'd have the amount of energy that would be produced. So it's going to be a pretty big number here. 2 exponent 8 divided by 298 divided by 0.082 times 572. Oops, let's make that negative. Negative 572 for this calculator. And multiply that, divide by that by 2 down here. Okay, so the amount of energy that's going to be evolved from here is your amount of energy, or amount of heat. How much heat was evolved is the question, delta H. Okay, your answer is going to be negative. It's going to give this off 2.3. Keep it with 2 significant digits here. Times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9th. Times 10 to the 9th kilojoules. And there is your answer. It's a doozy.